What is up, Flutter devs? The end of 2020 is almost here. Of course, none of us are going to be able to get together this year to enjoy the usual New Year countdown and celebration. So I thought, what better way to celebrate than with a Flutter video project? I had this idea for a mobile app that you could keep with you. You could open it up any time of day. It shows you the year, it shows you the time, it shows you an environment that roughly approximates the time of day. But then when the all-important time arrives, when we get within 10 seconds of the new year, a countdown begins. 9, 8, 7, until eventually, Happy New Year. The message we've all been waiting for, with fireworks going off in the background. I thought that would be interesting to create in a way that we can all kind of celebrate the new year together, even though we aren't technically celebrating the new year together. So over the next few videos, I'm going to show you how I built that kind of user interface. And with just a little bit of time remaining before the actual new year, you have time to also make it your own. So let's jump in for one last video exercise or set of videos in 2020. And after that, I'll see you in 2021. "2020 is drawing to a close, and as we all await with bated breath for the beginning of 2021, I thought it would be an interesting exercise to build a kind of New Year's countdown user interface. Not anything in particular, but something that I thought might be kind of neat. What I'd like to build here is a view as if we were looking over some mountains with a sky behind it, and that this environment, upon reaching New Year's, or within about 10 seconds of New Year's, you'd get your countdown, 10, 9, 8, blah, 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 down to 0, and then it would say Happy New Year, and some fireworks would go off in the background. And this is an app that you could keep with you on your device and open it up at the right time and catch the countdown. But because it's an app that you might have with you from now until New Year's, it probably shouldn't look like it's nighttime all the time. So I also had this notion that at different times of the day, the UI would change a little bit from morning to afternoon to evening to night. So whenever you open it up, it's roughly in the right visual state. And then, of course, when you finally get within 10 seconds of New Year's, you get the full-on countdown. So that's what we're going to try to build here. To get us started, I'd like for us to figure out the basics of the landscape. So again, I would like a sky in the background, and then at least at night, I would like some stars to appear on top of that, and then some mountains to appear on top of that. So let's get just a static, plain old landscape in here and go from there. Now, I have included a few assets with this, so you'll see me bring in assets primarily for the mountains and the stars. But the sky, we will begin with a gradient. So we'll use a gradient for the sky, a bitmap for the stars, and a bitmap for the mountains. And again, I already have those images in the project, so I'll just add them in where needed. So let's go ahead and get started here. We have a blank screen. All we have is a scaffold that contains nothing. I would like for us to have a stateless widget that we'll just call landscape for now, and we'll stick it inside of this scaffold. Now, I mentioned layering things, right? The sky, the stars, the mountains. This should immediately have us thinking about a stack, because we're going to stack layers coming out of the screen. That's what a stack does. Let's come in here and let's use a stack, and it's going to have some children. And we can be very literal with what we want these children to be. At the backmost or the furthest away layer, we want to build the sky. We haven't defined that yet, but we will. Then we want to build stars. And then we want to build mountains. So theoretically, if we implement each of those methods appropriately, we will get the user interface for at least, we'll start with the nighttime. We'll do nighttime first. So we'll get a nighttime environment, and then we'll figure out how to get morning, afternoon, evening, okay? So let's start by implementing build sky. And by the way, I'm going to comment these other two out for now just so we can actually render this without errors. But let's start with build sky. I want a gradient. I want a gradient that goes from the top of the screen to the bottom of the screen. And in the case of nighttime, we want to be in the purplish color, very dark purplish colors. I already have some gradients set aside for this, so we don't have to play with colors while we're doing this. But the point is, we want to use a widget that allows us to have a gradient from the top of the screen to the bottom with a couple of predefined colors. Let's go ahead and do that. We can accomplish that with a decorated box. Now, you could use a container because a container has a decoration property which you could use for this purpose. But essentially, the decoration in a container is what a decorated box gives us anyway, except we don't need all the other container stuff. So we use a decorated box widget, which takes a decoration property, which takes a box decoration, again, synonymous with a container in this regard, and then it's going to take a gradient. Now, I could write the gradient in line here, but we know that we're going to have different times of day, and each of those is going to produce a different gradient. So I'm going to put us in a slightly more configurable situation, and I'm going to say build gradient. And assuming that build gradient gives us what we want, actually one more thing is that without any further configuration, this decorated box is going to be 0 pixels by 0 pixels. So for the child, I'm going to give it a fully expanded size box so it grows to the size of the screen in this case. But assuming that build gradient does its job and gives us the gradient that we want, this decorated box will give us the display that we want. So let's go and implement build gradient. We could return a gradient in general, but we know in our case we're going to be dealing exclusively with linear gradients, so we can constrain the return type. So we will return a linear gradient here. Now, I've already chosen the colors that I want for this. You can choose any colors you'd like. So I'll just define these based on my notes. There's the first color. Here's the second color. And again, these are dark purples. Now, by default in Flutter, your linear gradient is going to go left to right, and that's not what we want. We want to go from top to bottom. So we'll take the begin and we'll go alignment top center, and we'll go end at alignment bottom center. Bottom center. Let's save that. Hey, we got ourselves a little bit of a gradient. So we start with a purple that is almost black, and then we go down to a brighter purple. Now, this area at the bottom is actually going to be covered up by some mountains, so this really intense purple down here we're not going to see. But the reason that we go from a very dark purple to a bit of a lighter purple, this has to do with light coming through the atmosphere. Obviously, if no light was coming through the atmosphere, everything in the sky would be truly completely black. But as light does come through the atmosphere, when we are looking out into the distance, there is less atmosphere above our heads than in front of us. Because when we look forward, we look through a bunch of atmosphere in front of us. But if we look up, there's kind of like, it's just the distance of atmosphere is less. There's more density of air in front of us than there is above us. The less dense the air, the less the light refracts. Light coming straight at us from the horizon accumulates, whereas there's less light coming from the top down onto us. This is similar to what happens during the afternoon and the evening when you see different colors above and below you, different shades. It has to do with the amount of atmosphere and the way that light is refracting. So just for anyone who didn't stop to think about it, the reason we don't have a solid color here is because when you kind of look up at night, it's actually darker than when you look straight ahead. That's what we're trying to capture here as well. So that's the build sky. We have the sky done. Now let's jump up and do the mountains in the foreground, okay? Mountains in the foreground. So widget build mountains. The mountains image has its natural bitmap size, and then there's also the size that we actually want it to display. Regardless of the size of the bitmap, we want it to be at the bottom of the screen exactly as wide as the screen. we're going to use a positioned widget for that because we're inside of a stack. So we get to use positioned, and positioned makes it very easy for us to accomplish that goal. So we can say that we want our image to touch the left side and be stretched all the way to touch the right side and touch the bottom. Those are essentially the constraints that we want. Within the positioned, we're going to go with image.asset, and I've called this mountainsnight.png. The fit, we want it to cover all of that available space. Probably actually doesn't make a difference in this case due to how we're positioning it, but cover is fine. So let's save that. And now we have some dark mountains, and the mountains are a lot darker than the sky, and that's because there's just not as much light bouncing off of those in and off of those mountains. I've painted some very minor highlights if you can see them near the top of the mountains, but that's about it. Other than that, it's more or less a silhouette. So those are the mountains as we want them at night. Now let's go ahead and let's build our stars in between. So stars are on top of the sky, but they actually don't intersect the mountains, but we know that if they ever did, the stars need to be behind the mountains, not in front of them. Those would be some crazy stars if they were in front of the mountains. At that point, more like some kind of pixie dust than stars. So we'll create a function here called build stars, and we will again return a positioned widget because the notion of where we want the stars to appear is easily described in terms of, in this case, left, right, and top. Once again, we want it touching the left, we want it touching the right, and we want it touching the top this time instead of the bottom. And now the child is going to be, I called this stars.png. Again, we'll set it to cover, though it probably doesn't make much of a difference. We'll save that. And now we have some stars, which if you want to paint those yourself, I accomplished that by just taking a spatter brush that just spatters paint on the canvas. And if you do that with some different opacities, you get something that looks vaguely like stars. This is our landscape at night. These are the primary pieces that we want for our landscapes. We've accomplished our goal here in the first step. What we'll do in the next step is we will introduce the ability for us to configure landscape to show as morning, afternoon, evening, or night, which we will make use of once we incorporate time. Now that we're rendering a landscape at night, let's go ahead and add different times of day and allow us to control those things. To do that, we're going to introduce an enum. We're going to call it environment mode. Values are going to be morning, afternoon, evening, and night. This captures all of the different visuals that we want to render for the landscape. Just going to go with 4 of them. You could go as elaborate here as you want, but we don't have all the time in the world, so let's just stick with these 4. Now, for every one of these 4 environment modes, we need different gradients for the sky. Now, I have different mountain images for each of them, so we don't need to worry about that here in code. We'll just choose different mountain images, but we actually need to define each of the gradients for the sky. So let me come up here and grab the gradient that we already have, which is good for night. Let me cut this out of here. I'm going to come down here and I'm going to say, we're going to say const night gradient equals what we already had. But we also want a morning gradient. We want an afternoon gradient. And we want an evening gradient. For the morning gradient, again, I'm just going to go off of what I have in my notes here. Once again, of course, we want a linear gradient. But this time for the colors, we're going to go with a bluish color, a light blue. And then it's going to fade to a white. So we can actually just say colors.white here. Once again, we need to get the beginning and end values. And, oops, press the wrong thing. Copy, paste, and then let's use this as the cookie cutter for the other two. For the afternoon gradient, oh, I'm sorry, the morning gradient, that was a yellow to a white, not a blue to a white. It's afternoon that has some blue in here. So for afternoon, we're going to go this color. There's that blue. And then we're still going to go to white, which again, of course, I can say with colors.white. So morning, we're going yellow to white because the sun is rising. We're getting that refracted light. We'll go with the yellowish. It could, of course, really early in the morning, it's still reddish, but we'll go with the yellow that comes after that. Then afternoon is blue because the position of the sun causes a different color in the atmosphere. And now we want evening, where we will go with red, shades of red. So here we're actually going to go with 4 different colors because the reddish orangish effect was needed to be a bit more nuanced in my opinion. So here's one color. Here's color 2. You can see on the left that we're getting shades of red/orange. Okay, and so now we've defined all 4 gradients: night, evening, afternoon, and morning. But what do we do with these? We know we destroyed our build gradient function up here, so how do we select those gradients? How do we know which one to go with? Well, we're just going to make this widget configurable. Up here, where we declare this stateless widget, we're going to have an environment mode variable that we're just going to call our property that we're going to call mode. Then let's generate the constructor. And then in build gradient, we will say switch on the mode case. Actually, we'll just generate the cases like this. We will return morning when it's morning. We will return afternoon when it's afternoon. We will return evening when it's evening. And we will return night when it's night. This is going to complain because technically it's possible for mode to be null and we don't have a default return statement. I'm going to ignore that and just make sure that we always have a non-null value. In a production context, you might want to be a little more careful. So let's go to morning and then let's save it. 1, 2, 3, save. Okay, there's our morning. The mountains look terrible, but the gradient is correct. After morning, we'll go to afternoon. Oh, and we see the stars are here. Let's solve this problem right now. So in build stars, let's say mode equals environment mode.night, then we want the stars. But if it doesn't equal night, then we want nothing at all. We'll just return a sized box. And now the stars are gone. After the afternoon is evening. Okay. And then night. And we get the stars back. We've got the gradient working for us. The stars turn on and off. The only thing we need to do beyond that is to switch the mountains. So the positioned and the asset widget can remain the same, but the path to the image should be based on a switch statement. So we'll call this mountains image path. Come up here, string mountains image path starts as nothing, and then we're going to switch on the mode again. We already know what it is for nighttime because I just cut it. It's that one. For evening, I'm pretty sure it's just underscore evening and underscore afternoon and underscore morning. Let's save. We're still night, so nothing changes. That's as expected, but we'll come up here and now let's go to morning. Okay, now we've got some brighter mountains that are yellow shifted with some brighter highlights. That's what we want there. Afternoon. Okay, now we have some blue shifted mountains with some lighter highlights. And then evening, save that. We've got some red shifted mountains. So these are just 4 different bitmaps that I created, one for each environment mode. All right, so we've taken one big step in the right direction. We can control what time of day it looks like on the screen. However, a couple things here. First, as time goes by, and we haven't hooked up time yet, but as time goes by, when you go from afternoon to evening, it's going to flip like that. If you happen to be there when it happens, that's going to be a pretty jarring effect. I think it would be much better if it just quickly fades from the first one to the second one, from one to another. So we should come back in the next step and we should create an animated transition for the environment. Second, when you're producing a product where time is mission critical, or any event is mission critical, you really want to write some tests that make sure that the scene changes when you and as you expect it to change. So we're actually going to come back in the next step and also add some tests that make sure that when the environment says it's morning, it looks like morning, afternoon looks like afternoon, evening looks like evening, and night looks like night. So we'll get a little bit of testing experience in here too, and that's in the next step. Let's get some animated transitions in here between the different times of day. The first thing we have to decide is how long we want the transition to run. I'm going to go with just a half a second. So I'll define a constant, which is the switch mode duration, and that's going to be a duration of 500 milliseconds. Set it to whatever you want. We're going to go 500 milliseconds, and then the question is, how are we going to do a transition? Because we're working entirely with widgets in this particular UI, there's actually a really easy way to get a simple transition from one widget to another, and that's using something called animated switcher. So let's start with the sky. Let's get that transitioning first, and let's surround our decorated box with an animated switcher. Now it's going to want a duration, and we can provide, what did I just call that? The switch mode duration. How this works is that the animated switcher watches its child, and if the child changes, it holds on to the previous one, it holds on to the next one, and it paints them both, fading from one to the other. So it holds on to both of them, paints both of them, but fades, essentially fades the new one above the old one. In fact, it probably fades the new one in as it fades the old one out. I haven't looked at the implementation. But you might be wondering how it knows exactly when to do this. How does it know when the child tree has actually changed and should be faded? We have to give it some help here. This is where we use the key property that you see on every widget that you've ever used. We will provide a value key. Every time the value key, or key in general, changes, that's an indicator to the animated switcher that it needs to switch between the two. Because you don't always want to, like, there are changes you might make inside your child that you don't want to fade. So the way that you make it clear that you do want to fade is that you change the value of the key. The animated switcher sees the key change and it says, okay, fade from this to this. As long as we provide different values for the value key, the switcher will recognize fade from this to this. All we have to do in our case is pass in the mode. Because every time we want to fade, every time the mode changes from morning to afternoon, afternoon to evening, evening to night, we want to fade between all those, right? So every time the mode changes, that's a different scene we want to fade. If the mode doesn't change, we don't want to fade anything. Let's save that. Nothing changes because we're in the same mode. But now let's go from evening to night. Check out that fade that we just got in there. From night to morning. There we go again. And from morning to afternoon, another fade. That's how easy it is to fade the sky scene. And it's just about that easy to fade the mountains too. We just need to be a little more particular with our order of widgets. So down here in build mountains, we still want to do the fade effect, because you notice that our sky faded, but the mountains again are jumping like that instantaneously. The slightly different detail here is that positioned widgets must be the direct child of a stack. If we surround positioned with an animated switcher, we're going to break positioned. We can't put the animated switcher around positioned. We have to put it inside of positioned. So we'll come down to the image asset and we'll wrap that with an animated switcher. The duration will again be the switch mode duration. And once again, we need to make sure that the animated switcher knows when we want it to transition. So again, we will pass in a value key with mode, and that needs to go below the image path. Let's save that and then come back up here from afternoon to evening, from evening to night, from night to morning, and from morning to afternoon. So now we've got all of the fading that we want. You may notice that we're not fading the stars. That was a choice that I made because I don't think it makes any difference. I mean, if we go to evening and then from evening we go to night, I don't think having the stars appear suddenly is hardly noticeable, so I'm just not worried about it. But you can fade the stars in the same way, or pretty close to the same way that we faded the mountains. You'll just need to deal with instead of fading one image to the next, you're fading from an image to nothing and from nothing to an image. But otherwise, it's the same process. Now, I mentioned in the previous step about testing. Once we have this landscape rendering the way we want, we really want to make sure that it keeps rendering the way we want. Whatever other changes we make in this app, we want the landscape to look exactly how it looks right now. And this is one of the primary uses of tests, is to lock stuff down so that all those terrible developers that you work with and all their bad decisions, they can't screw up your work without failing a test. So let's see how we can use tests to help us out here. We're going to make use of golden tests, otherwise known as screenshot tests. So literally, we're going to paint this UI to a file, and then we can run the test. The test will paint the UI again and compare it to the file. And if the UI that it paints in the test doesn't match the file, the test fails and said, these don't match. Now you can write golden tests using just what comes with the Flutter tooling. You don't need anything more than that. However, I find that it's much quicker to use a particular package called Golden Toolkit. And at this moment, I think 0.80 is the latest, or there may be a null safety version, but I'm not using null safety. So for me, 0.80 is the latest that I'm using here. So you can bring Golden Toolkit into your project. Again, you don't need it. You can do all this without it, but some things are simplified by using Golden Toolkit because it does some of the work for you in terms of testing. So go ahead and put that in your project if you want it, obtain dependencies. Beyond that, we need a test directory where we're going to write our tests, and we'll create a landscape_test.dart. Now, within a test file, we're going to define an entry point for the program because Flutter tests and Dart tests are actually just Dart programs that happen to use the testing package. Otherwise, it is truly a normal Dart application with a main method that just runs. We are going to use a method here provided to us by Golden Toolkit, which is, let's see, test goldens, I think. So test goldens is a method that declares a test that is intended specifically for golden tests. And we will say landscape goldens. We provide our callback that actually runs the test here, and this gets us started. But I'm going to define a tool here before we get any further, because By default, golden tests render at 800 by 600 pixels. Now, aside from being kind of small, that's also the completely wrong aspect ratio for our use case. We are building a UI that is truly intended for a phone, an iPhone, an Android phone. It will not look correct on a largely, rectangular landscape style screen. And that's okay. We know that going in. We don't want to test that. We essentially want to render exactly what we see on this simulator. We want to render at an iPhone kind of size and aspect ratio. We do have control over this within the testing suite. I'm going to build or define a method in a dedicated file. So I'm going to come down here into the test directory, and I'm going to create a file called test tools. I'm going to define a function that we can call from anywhere that will resize the golden file to look like an iPhone size. In fact, I will call it configure to look like iPhone 11. And we'll take in the widget tester, which we need. In here, and you don't need to really understand what we're doing here. You can just use what's here for your own project. You can look into the implementation of this later, but I'm just going to show you how to accomplish this. Given the widget tester that is available to every widget test, we're going to access what's called its binding. And then there's a window inside the binding, and we're going to change the physical size during tests. So the physical size test value, what that means is the size of the window during a test. So this is a property that was created specifically for testing purposes. And here we're going to utilize a little bit of information from the Golden Toolkit. There's a class called device provided by the Golden Toolkit package, and it has a property called iPhone 11, and we can just ask for its size. Now this is just a hard-coded size. I guess this went to the abstract class, but there's the iPhone implementation. Let's see if we can get there. Here's the iPhone 11 implementation. I just didn't want to look these values up myself. They're already defined inside of Golden Toolkit. The logical size of the device, this device pixel ratio. I don't think we're going to use safe area, but it's available. So again, we can just access that as a predefined set of values using Golden Toolkit instead of looking it up, which is what I'm doing here. So physical size, the pixel size of the canvas that we're going to paint, that's one thing we need to define. We also, on the binding, and actually it's occurring to me now that I don't need to repeat all of that stuff. I think we can just do double dots here. We can use what is called cascade operator. And so with that window, we change the physical size. We also need to set the device pixel ratio. Again, for testing purposes, device pixel ratio test value. That's device iPhone 11 device pixel ratio. And we need to set the text scale factor test value. So device iPhone 11 text scale. By invoking this method with a widget tester, we will cause any screenshots generated by that test to now render to the dimensions and the density and the text scale of a typical iPhone 11, which is not the simulator I'm running here, but it's pretty close. It's close enough. Let's save that. And then we want to make use of it right here at the beginning of our test Goldens call. We want to say configure to look like iPhone 11 and pass in our tester. And now after this, any files that we paint, they're going to be the size, generally speaking, of an iPhone 11. What next? Well, we need to paint something, which means we need to order a painting. We need to say tester pump widget. This tells the testing infrastructure to essentially paint a widget tree. It doesn't actually do the painting at this stage, but it's how we tell Flutter what we want it to theoretically paint in our test. Now, there is no other part of the widget tree. Like we are truly at the top level of Flutter when we're in a test, which means we need to remember to start with Material App or something like it. Otherwise, we're going to get very unexpected results. Within the Material App, we just want to render one screen, so we'll use the home property. We also need to remember a scaffold. Now, let me look back. Maybe I already had a scaffold in here. Okay, I did. However, it's not the New Year's countdown screen that we want to test. It's landscape, because landscape is what takes in the mode. We want to test different modes, right? So what we want to test is landscape, not this higher up widget. And landscape does not contain a scaffold. So we also want the scaffold here. Scaffold gives us base material styling. If we don't have a scaffold, things can look really weird as well. You could also just throw a material in there, but because we know that we're going to use a scaffold in the real app, we might as well do the real thing here, which is use a scaffold. Then within the scaffold, we can finally say landscape, and let's import that. And then to begin with, we're going to go with environment mode morning. We'll go morning, afternoon, evening, night. Now this creates the widget tree that we want, but it doesn't paint anything to a file. It doesn't really paint anything anywhere because that's not how the testing system is designed. We could interact with this. We could tap on stuff conceptually, but there is no real rendering of pixels anywhere. This is where painting Goldens comes in. Now, again, you can accomplish this using the APIs that come with Flutter out of the box. We're going to use a slightly more convenient version of the APIs, which is provided by Golden Toolkit. We are going to say await screen matches golden. We're going to pass in the tester, and we're going to give a name for our file. We're going to say landscape morning. With Golden Toolkit, we do not provide an extension. We just provide the name of the file. It's going to automatically be a PNG. So let's save this, and let's make sure that this actually does what we think it does. To run this, we're going to need to use the terminal because we're going to need to provide a parameter here. We're going to need to say, so normally we'd say Flutter test test landscape test. This runs the test, but we haven't generated any golden files yet. So there are no files to compare against, and our test will fail. Instead, we need to initially generate Goldens using this flag, Flutter -- update Goldens. Now, every Golden test that is run, it won't compare to a file, it will just generate a file. So update also, it's not just updating them, it also means the very first generation. Update Goldens means you're going to create all the Golden files that show up in your test. So let's run that. And excuse me, I have this in the complete wrong order. It is not Flutter that updates Goldens, it is Flutter test that updates Goldens. Taking some time to generate files. Okay. Now here we have a Goldens directory that has appeared on our behalf under test. Open that up. Open this file. And look at that. There is what we expected for morning. It's taller than the simulator, and that's because the iPhone 11 has the notch at the top. So the iPhone 11 actually is a taller screen than the iPhone 8 or 7 or whatever the simulator is supposed to be. Now, I don't want this debug banner up here, so let's go get rid of that. Here in Material App, we will say debug show banner is false, and now let's regenerate that file. Okay. And now that banner is gone. So this is one of our Goldens out of the way. We want 3 more. But I don't want to repeat this whole little tree 3 more times. I'm going to extract it because other than the mode, it's exactly the same. So we're going to say build landscape. We're going to create a function called build landscape. It's going to take a mode, and it's going to return this widget tree. We're just going to parameterize the mode here. Now, every time that you make a change to a test like this, before we go any further, we should make sure that we didn't break what we already created. So let's say Flutter test, no update goldens this time. We're not generating new ones. We're comparing what we've already got. All tests passed. So our test generates exactly the same pixels that it did previously, which is what we want. Now let's copy this 3 more times. And then we want night. We want evening. We want afternoon. This time, we do want to update goldens again because these other 3 don't exist yet, so the test will fail. Let's go ahead and generate the other 3. Okay, now we have 4 files here: morning, afternoon, evening, and night. Everyone is exactly what we want them to be. So now as we continue making changes to our code, every time we run our test suite, we're going to expect these same 4 images. If the rendering ever changes, the test will fail, it will show us the difference, and we'll have an opportunity to catch a mistake. I think that golden tests are by far the most underutilized option for Flutter testing. There are a lot of widgets and user interfaces where even if the interactions work, even if you can tap on things and text exists somewhere, you care a whole lot about how it looks. It's not just the ability to tap on something that matters. It needs to look the way you expect it to look, especially on different screen sizes. That's really easy to check with golden tests. You know, with a single, they say an image is worth 1,000 words. In this case, a golden is worth 1,000 lines of widget code. You can validate so many details with a single image and avoid writing so much widget testing code. So I think golden tests are definitely something you should become comfortable with if you're not already, and you should make heavy use of them. Now, back to what we're actually working on here. In the next step, we're going to introduce just a little bit of text to show us the current year and the current time, and then we're going to start getting into some of the more interesting details like the passage of time and eventually the countdown and celebration. It's time for a little bit of text. Down here where the mountains are, I would like to show the current year in large text and then the current time in some smaller text. Let's get the text positioned, and then we're going to have to figure out this whole passage of time thing. Let's add a couple parameters to landscape. We're not going to do the time processing here. We're just rendering what we want. So let's take in a time, which is a string, and we'll take in a year. By taking these in as strings, we're able to separate the problem of layout and rendering from the problem of dealing with time over time. It's easy to work with strings. It's not as easy to work with date times. So let's solve problems. Let's encapsulate our problems and solutions. Now we have this stack of things that we're rendering. We essentially want text to be the most foreground thing. we're going to define build text. We'll implement that, but we want the text to sit on top of the mountains. So we'll come down here below all of our existing methods and we will define build text. Similar to a couple of our other implementations here, we're going to begin with a positioned widget because it's pretty easy for us to say where we want our text to appear. In this case, we're going to say left 0, right 0. So we're going to stretch this content full width of the screen, but we're going to leave a little gap with the bottom of 16 pixels. Position takes a child, but we don't just have one piece of text, we have two. And they're styled differently, so we can't throw them into the same text widget. Therefore, what we're going to use here is a column. So we'll create a column, and we don't want the column to expand as large as it can be. We want it to be as small as it can be. So the main axis size is going to be min. And then it's going to take children. We're going to give it 2 text children. The first one, the one on top, is going to be the current time, and the text alignment will be center. And here's the style, text style, color. For the moment, I'm going to go with white, but we're going to change that in a moment. Font size 20, font weight, I'm going to go with a font weight of 900. Then we're going to go with a second text widget. This time it's going to display the current year. Text align again is the center. Now the column, by the way, automatically centers things for us, but if the text were to somehow get too long and wrap to the next line, we want the text to be centered within the text widget, which isn't going to happen in this case, but it's good to always define the text alignment just in case. And then we want to style this. Color, again, I'm going to go white for a moment, but we're going to change that. Font size 52, font weight 900. Save that. We need to actually give it some values for that. So let's come back up here to where we actually declare our use of landscape, and for the time, how's 8:40 p.m. sound? And then for the year, clearly we're still in 2020. Let's save that. Okay, now we have the text where I want it and the size that I want it. The only thing I'm unhappy about is the color. It's far too bright for night. Really, I would like the color once again to be based on which environment mode we're in, which means we need another 4 colors. So in my notes here, I have 4 colors for us. Let's go ahead and add those down here at the bottom along with our gradients. We have a morning gradient. Let's define a morning text color. All right, it's a kind of a dark muddy yellow or a dark gold, something like that. Now we want an afternoon text color. Then we want an evening text color. And finally, we want a night text color. And then we need to use those colors. So here we have build text. Let's create a build text color. And we will switch on the mode. Again, generate the return values. We will return the night text color here. We will return the evening text color here. Afternoon text color here. Morning text color here. Then we need to replace white with build text color. All right, now we got a purple for night. Let's go check the other modes. Morning, have that golden color, kind of matches the highlights of the mountain. Afternoon, once again, matches the highlights of the mountain. Evening, okay, and night. There we go. So that gives us a little bit of text. We're now ready in the next step to figure out what on earth we're going to do about the passage of time.